Hi, I'm from Social Research Insights, and in this video cast I'm going to explain how to compute a Bartlett test of homogeneity in Libre Office Calc installed in Ubuntu version number 14.04. The mission of Social Research Insights is to promote open source software for both academic and corporate research. There is a wonderful page described for Bartlett test on Wikipedia. You can just go to that. I also use the same page in order to compute the calculations for Bartlett test of spherecity. The main assumption of the Bartlett test of spherecity is that the variances in the population are actually equal, and the alternative this is in fact regarded as a null hypothesis, and the alternative hypothesis is going to be at least two variances, variance for at least two samples is not equal. So we are actually going to test the null hypothesis by computing the Bartlett test of sphericity or the test of homogeneity, and this is the formula for the Bartlett test. The measure computed through this formula roughly follows the chi-square distribution, and after computing this Bartlett test measure, we have to compare that value with the theoretical value of the chi-square distribution in order to make the inference. Okay, so this is the Libre Office Calc, which is installed in Ubuntu 14.04, and both of them are open source software and they are freely available from the website. You can just go and check up, and in case if you are interested, you can download them at free of cost and install in your computer. And we always advise the open source software for the data analytics for both academic and corporate research needs. And I have the same formula here, which is actually a screenshot I made and saved in LibreOffice Calc. If you closely observe, this formula has got two parts in numerator and two parts in denominator. In the first part of the numerator, actually the capital N minus K, where the capital N is the total number of data points in your sample data set, and I have 5 data variables, so in which each sample comprising of 30 data points. So my total number of the data, the size of the data set here is 5 multiplied by 30, which is going to be 150. So here you can see that capital N is equal to 150, and K is the N minus K, where K stands for the number of data variables. In my case, there are 5 data variables, and N minus K is actually the value which we need to compute in order to finish the first term of the numerator. And log sp square is the part of the first part of the numerator, and sp square is the pooled variance, which is calculated from the variances of the sample sizes. So you can see in the formula bar var, I used a function var in order to compute the variance for the first sample, and I just copied this cell value to the rest of the cells so that LibreOffice Calc automatically computes the rest of the variances. See here, I call them SI square. See that part of this is the SI square, which is in fact the variance of the sample. And after that, I computed the SP's, the pool variance. Here you can see that 1 by N minus K multiplied sigma SI square through the variances which I computed from the samples. Here you can see the N minus 1 multiplied A33. A33 is the variance, SI square. This is actually the N minus 1 multiplied SI square. So which, when we sum up, that will going to give us the pool variance, where we can say N minus I SI square. Here you can see I computed the total value, that 1 by N minus K sum of N minus I SI square as required by the see here 1 by N minus K N minus I SI square. This is actually the SP square, and I just have to take the SP square as it is here. So I think by mistake I have computed the once again So this is actually the SP square. SP square is going to be the n minus 1 multiplied variance, and here you can see I divided it with n minus k, where in j3 I have n minus k. So we are going to compute the pooled variance 1 by n minus k, 1 by here you can see 1 by n minus k, 1 by n minus k multiplied the sum of the n minus 1 si square. That is pool variance, which we can finish with the by using 1 by n minus k and ni minus 1 si square. That is the pool variance, and we have to take the log values of this this pool variance in order to, you see here the log si square, n minus 1 log si square, that in order to compute the log sp square, sp square, here we can compute the log value of the sp square right from you can see the log j4, which will get log sp square, and we compute this n minus 1 this log si square straight away from here, because this is the sum of the n minus 1 si square, and we are going to take that value exactly straight away. See here 0.49, 0.454, and we will be, this is the second part of the numerator. These two are the first part of the numerator, where n minus k multiplied log sp square, you can see that in formula, n minus k multiplied log sp square. We are going to use these two things in order to find the first part of the numerator, and second part of the numerator is already ready. So we just have to compute the denominator, where it is going to be 1 plus 1 by 3 multiplied k minus 1 sigma 1 by ni minus 1. Here the sigma, in the sense I have to compute this too, 1 by ni 30 minus 1, 1 by 29 minus 1 by 150 minus 5, which is going to be 145. So this I have to sum up, which means I'm just going to multiply with 5, because I have 5 data variables. That you can see here. See the n minus k multiplied j5. j5 is log sp square. So this is the first part of the numerator, and the second part of the numerator is going to be j6. Where is the j6? This is j6 sigma n minus 1 log si square. This is the second part of the numerator, and my numerator is over, and the denominator 1 plus j10. What is in j10? j10 we have this value 1 by 3 multiplied k minus 1. You can check that here. 1 by 3 into k minus 1, that is the second, and I'm going to multiply that value with the rest of the part. See here, I'm going to multiply star value, and j9, in j9 I already have that value, so 1 by n minus 1. So I just have to prepare this numerator and denominator in part by part, and after that I have to substitute in the formula to get the chi-square value. So this is the chi-square value, and I found the theoretical value for the chi-square statistic. The degrees of freedom is going to be 4, because k minus 1 is equal to 5 minus 1 is going to be 4. At 5% confidence significance level, my theoretical value for chi-square statistic is going to be 9.48, and if you observe, the calculated value is far high compared to the theoretical value, so whereby we are rejecting the null hypothesis. In order to cross check my inference, I also computed the p-value. You can see that chi distribution j12 is actually the calculated chi-square value, and 4 is the degrees of freedom. So the p-value is going to be 0. Here you can see e to the power of minus 87, which is 0. So we have enough evidence in support of the alternative hypothesis that at least 2 variances in the population are not equal. So the homogeneity actually violated in this the data set, and which is a positive signal for the factor analysis. Thank you.